Okay, here in example 3, this is very nearly factored completely, but not quite. If you'll look at the first factor, 3x minus 3, a 3 can be factored out of that. So I'm going to go ahead and take out a 3. That'll leave me with x minus 1, and then the x plus 4 divided by x plus 2 squared. And so notice that nothing cancels out, therefore I'm not going to have any wholes. And then the roots come from the numerator equaling to 0. And so that's going to happen at 2 different x values this time. The first one would be 1, 0. And the second one is going to be negative 4, 0. And so I'm going to plot 2 points, negative 4, 0, and 1, 0. And those are the only places where I'm going to be allowed to touch the x-axis. Okay, vertical asymptotes come from the denominator equaling to 0. We write our answer as x equals a number. In this particular case, that would be x is equal to negative 2. So at negative 2, I'm going to draw a vertical asymptote. Okay, the T stands for tangency or togetherness. What you're looking for are squared terms in the fully factored version. And so here I see that I do have a square on the x plus 2. Therefore, since that's in the denominator, it's about an asymptote, and so we're talking about togetherness in this particular case. We have togetherness at x equals negative 2. And so again, what does that mean? That means that on that particular portion of the graph at x equals negative 2, you're either going to have up on both sides, or you're going to have down on both sides, just depending on what else is going on with the graph. Okay, next thing is end behavior. So end behavior is found by looking at the original version. So if we look at the original version, it's actually somewhat difficult to tell because it's actually somewhat factored in this case. So here's my piece of advice. Don't multiply all of this out. You don't need to do that in order to figure out the end behavior. Just multiply the biggest terms. And so if I multiply the 3x from this parentheses by the x from that parentheses, that's going to give me 3x squared. And if I look in the denominator, I'm going to have an x plus 2 times an x plus 2, which is going to give me an x squared. And so 3x squared divided by x squared is going to give me a 3. And so y is equal to 3 is going to be my horizontal asymptote here. And so y equals to 3 would be up here, and that's going to be my horizontal asymptote. Okay, last thing is the y-intercept. We want the x-coordinate to be 0, and so doesn't really matter necessarily which version you use here. They're both about the equal amount of difficulty level. So if I do the top, that's going to be negative 3 times positive 4 divided by 2 squared, and so that's going to be negative 12 divided by 4, which is negative 3, and so 0, negative 3 is going to be my y-intercept. Okay, so we're ready to start graphing this. There's one vertical asymptote. That means there are going to be 2 sections to this graph, one of them somewhere over here and the other one somewhere over here. And so am I going to be above this horizontal asymptote, or am I going to be below it? Well, hopefully you see this point right here. We know that we have to go through that point, and so I'm going to have to be below the horizontal asymptote, cross through that x-intercept since there's no tangency, and go down like that. And then, am I going to be above or below on this side? Well, hopefully you said not here, because I've got to go through these 2 points, and I've got to have my togetherness at that asymptote. And so I'm going to come along the asymptote here, cross through that root, go through my y-intercept, and go down that direction. Okay, example 4's got a lot going on. We've got 4 different factors here, and please help me remember, I know you can't do that because you're watching this after the fact or not live, but I'm going to try to help myself remember by circling that negative in the front. I've got to remember that that's there for later on. Okay, completely factored already. Does anything cancel? Answer to that is a quick no. Nothing is going to cancel out. Roots come from the numerator. So the numerator is equal to 0 at negative 1. That's going to be my first root. And then my other one, that's an and sign, by the way. I know it doesn't really look like it. I'm not really great at making that sign, but that's what it was meant to be. 2, 0 is the other root. And so 2, 0 and -1, 0 are going to get plotted on the graph. Okay, vertical asymptotes are when the denominator equals 0, so that would be x equals -3 and +4, so -3 will be right here, and +4 is going to be all the way over here. Not the straightest of lines, but that's okay. We're not looking for perfection necessarily. Now, tangency and togetherness, and I use the word "and" there purposefully because we have both in this particular function. We have a squared on the top on x minus 2. What that tells me is that at 2, 0, we are going to be tangent. We also have a square on x plus 3 in the bottom, and that's an asymptote. So at x equals -3, the graph is going to come together. Now, what else we're going to be able to figure out from that is that at x equals -1, at this root right here, we are going to actually cross the x-axis, and at x equals 4, we are going to be not together. And so you're really saying something without saying something on that t, if that makes sense. Now for end behavior, again, we don't have to multiply all of this out. We do have to remember that there's a negative in the front there, so I am going to do that. So here I'm going to have a negative, I'm going to have an x times an x squared, and x times x squared is going to be x cubed. And then in the denominator, we're going to have an x squared multiplied by an x, and so that's also going to be x cubed. And so the exponents are the same. We're going to divide the coefficients and get y equals to -1 as our horizontal asymptote. Okay, so y equals -1 right there. Let's see if we can do a little better job underlining that word. There we go, horizontal. And then finally, the y-intercept, we've got a negative in the front. We're plugging in 0 for x, so that'll be 1 times -2 squared divided by 3 squared multiplied by -4. And so in the numerator, I'm going to have -4, and in the denominator, I'm going to have 9 times -4, so that's -36, which is going to be +1/9. So 0 and +1/9, which is just barely above that x-axis on the positive side. Okay, here we go. There is a lot more going on in the middle than there is on either of the outside pieces. So you could start in the middle, but it's going to be easy to start on the outside as well because of the fact that I cannot cross the x-axis anywhere but a root. And so since I don't have a root over here, I know that I can't draw my graph up here, because otherwise what will happen? I will cross through the x-axis somewhere over here, and so therefore I've got to be below the horizontal asymptote so that I do not cross through the x-axis. Okay, that's really helpful, because now what do I know about this asymptote? I know that I have togetherness at that asymptote. So to have togetherness, I've got to start from the bottom here, and I'm going to come up that asymptote and come to that particular root. Now at that root, did we have tangency or togetherness? Well, I'm sorry, did we have tangency? Well, we did not have tangency, so therefore I'm going to cross through that root and go to my y-intercept. The next place I'm going to go is I'm going to turn back down and go to my next root. And at that root, we did have tangency. And so we're going to come down and touch that x-intercept and then bounce right back up. Okay, for the final section, I know two things. I know that I cannot draw it here because that would force me to cross through the x-axis, which I know I can't do since I don't have a root there. And I know that at this asymptote, I do not have togetherness, and so therefore I know that the graph has to be down in this particular section. So hopefully this is making sense. Hopefully you kind of see it as a puzzle that you just have to put all of the pieces together. I personally think this is incredibly fun, and I know I'm probably in the minority there, but This is honestly one of my favorite lessons of the entire class. And so if there's not anything that's something that's not making sense about this, please let me know and we can work more examples. I do have one more example, example 5, that's a little bit different than the rest, but hopefully you guys are doing okay. Okay, last example for your notes, and then you'll have a chance to try some questions on your own. So if we look at this, x squared plus 1 in the numerator is already factored, so there's nothing to do there. X in the bottom is just a single term, so there's nothing to factor there. This is completely factored, and so I'm ready to jump into finding the information. So first thing, nothing cancels, therefore I'm not going to have any holes. Roots come from when the numerator is equal to 0. If you set that equal to 0, you are going to get imaginary numbers, and we don't put imaginary numbers on the graph in the real number system, and so there are no roots on this particular function. What that means is that I'm never going to cross the x-axis. Okay, vertical asymptote is when the denominator is equal to 0, and that would happen when x is equal to 0, and so here on the y-axis I'm going to have a vertical asymptote at x equals 0. Tangency and togetherness. Now be careful there. You do have a squared here, but the squared is not really on a factor. And so there's no tangency here because there's no root. And hopefully that makes sense to you, that if you don't have a root, you can't possibly have tangency. And then there's no togetherness because the x in the denominator is not squared. And so we're not going to have any tangency or togetherness. Now in behavior, horizontal or slant asymptote. Hopefully I maybe have not said that to this point, but oblique is just meaning the same thing as slant asymptote. Well, here we are bigger on top, and we are bigger on top by 1. And so therefore that means I'm going to have a slant or oblique asymptote. And so revert back to your previous notes on section 2.6. How do we find a slant asymptote? We synthetic or long divide. Now, because we're dividing by x, we can actually use the synthetic division method here. It's a little bit easier than long division. And so we're going to divide by 0 and list the coefficients. So that would be 1. Be careful, there is no x term, so we're going to put a 0 there as a placeholder. And remember, we don't care about the remainder. Drop the 1. 1 times 0 is 0, 0 plus 0 is 0, and so I've got a slant asymptote at y is equal to x. And so that's a pretty easy line to sketch. I'm just going to sketch through y equals x, just like that. And then finally, the y-intercept is when x is equal to 0. Well, that's going to give me 0 squared plus 1 divided by 0, which is 1 divided by 0. And that's undefined. And so what that tells me is that this graph is not going to cross the y-axis. And we knew that already because the y-axis was a vertical asymptote, and a graph can never cross one of its vertical asymptotes. Okay, so there's one vertical asymptote in this graph. That means there's going to be 2 sections. One of them over here to the left of x equals 0, and another over here to the right of x equals 0. And so the 2 options over here on the left side are either going to be here or here. And so which of those 2 do you think it is? Look back here and notice that you don't have any roots. Is it possible for me to draw the graph like this? Notice what the laser pointer is doing. It's going right through the x-axis. I can't draw the graph there. It's got to be drawn right here in this little space here. And now, since we don't have any togetherness and we don't have any roots, the other part of this has got to be drawn up above. And so here's what my graph looks like for example 5. If you guys have any questions on RATEY method, please reach out to me and let's get those taken care of together. Otherwise, you guys have a great day.